Hello, my name is Shane Mehdi. Today is the 17th of February 2016, and today I'm going to try prove the theorem to you that an angle subtended by an arc at a centre is twice the angle subtended anywhere else. So first of all, I'm just going to sketch this idea out. This is our centre. Okay, so we're basically trying to prove that the angle here, A, is twice the angle above here, angle B. So I'll just write that down so you can see it. 2 times angle B equals angle A. So that's what we're trying to prove here in this theorem. The first thing we do to prove this theorem is we draw from the point AB, we draw here through the centre at this line here. Now when we do that, we create two triangles. We create two isosceles triangles. The reason that these are two isosceles triangles is that the length of the two sides are the same, and that creates an isosceles triangle. So I'll just mark these in here. So that there are two isosceles triangles created. We then label angles. So let's say we'll say the angle here. We'll call that angle 1, and we'll call in here angle 2. The reason we're calling two of them the same, that angle in here, angle 1 and angle 1, is because there are two isosceles triangles. So the two base angles are going to be the exact same. Now earlier I've drawn out a bit of a clearer sketch, so it's a bit handier for me to explain. So this is basically the same thing. As you can see here, the only difference is you can see I've marked my two isosceles triangles, but I've marked additional angles, angles 3, 4, 5 and 6. So all we've really done is drawn this line and noted we have two isosceles triangles, and that the two base angles are the same. So from here, what we're going to do is we're going to note that all the angles here in the two triangles are going to equal 180 degrees, and that's just plain common sense. So what we're going to say is that the angle 1 plus angle 1 plus angle 3 equal 180. Likely that angle 2 plus angle 2 equal plus angle 4, equal 180 degrees. And that's just because all the angles inside any triangle equal 180 degrees. So this is for triangle 1, we're saying this here. And we're saying this for triangle 2. Another thing we know about, we can point out about all of these angles, is that the angle 3 and 6 is a straight angle, likely 4 and 5 is. So we're just going to point that out. So angle 3 plus angle 6 equals 180 degrees. Likely angle 4 plus angle 5 equals 180 degrees. So you can see that there for yourself. Angle 3 and 6 equal 180 degrees. Likely angle 4 and 5. So what we can do from here is just draw up triangle 1. So what do we know about it? As we said there, 2 times angle 1 plus angle 3 equals 180 degrees. And we said here, angle 6 plus angle 3 equal 180 degrees. So if you take note that these two are the exact same, we can also come up with the idea that 2 times angle 1, 2 times angle 1 plus angle 6 equals 180 degrees. And if we go the far side and see what do we know about angle 2, we can see triangle 2, we can see that 2 times angle 2 plus angle 4 equal 180 degrees. Likely that angle 5 plus angle 4 equal 180 degrees. So we can also pull from that the 2 times angle 2 plus angle 5 equals 180 degrees, because these two are similar, so that means angle 2 times angle 2 and angle 5 will also equal 180 degrees. So we're going to pull these two figures now that we found, and we're just going to pull them down here. So because the way they're equal up to each other, we can say that 2 times angles 1 plus 2 times angles 2 equals angle 6 plus angle 5. And suppose if you're to shorthand that up, you can say 2 times angle 1 plus angle 2 equals angle 6 plus angle 5. And if you look initially, that's what we're trying to prove, that angle 6 and 5 is 2 times angle 1 and 2, and that is our theorem proved.